All right, let's see the second example, example 2. So in this example, it says accident used to occur on the road junction at the rate of 6 per month. After a special limit is placed on the road, the number of accidents in the following month is 2. Okay. The planner wishes to test at 5% level of significance whether or not there has been a decrease in the rate of accidents. Okay, so first from looking at this, I know this is going to be my alpha, right? And the rate, see, rate per month, this means it's going to be per song. This is lambda for sure. Okay, now what happened after you place the limit? The accident reduces to 2. All right, let's say this. Suggest a suitable test statistic. All right, this is my test statistic. First line. See? So the test statistic is number of accident. You don't have to put the value. You just have to say that what is, so if I highlight it, the rate, the number of accident, road junction accident rate per month, right? So I didn't put any number. I just say this is my test statistic. Then second step is you write down the two suitable hypotheses. First one for sure that this is 6, the null hypothesis. And the second one less than 6. We don't say it's equal to 2, yeah? We just say it is less than 6. This is the alternate hypothesis that the accident had reduced. Okay. Then next, you have to explain me the condition under which you want to accept or reject the null hypothesis. Okay, so the condition is quite simple. We just say that if the probability of getting 2 or fewer accidents is less than or equals to 5%, then the null hypothesis is rejected. Okay, let me explain this way. I'll just write it out so you see the picture. Suppose this is what we are looking at. Okay, and we're saying this is less than, right? Less than mean it's going to be one tail. All right. So I don't know what this value is, but what I do know is that this alpha is 5%. 5% is here. So I need to check whether if I put the value of 2 in here, okay, is, sorry, is the value of 2 going to be in this region? Okay, if 2 is in this region, okay, if it's outside, then we reject 8 now. But if 2 is in here, so if 2 was somewhere here, okay, if 2 was here, then we say we accept, okay, H now. So we have to test that, right? So for you to test this, what you need to do is you have to use the concept or the table that I have given to you before, right? We look at lambda. Lambda was 5. Then you look at n, right? 0, 1, 2. And then you look at the probability here. If it was 2, how much was it? Yeah. Then you check if this is, let's say, let's just pick a number at random. I didn't do it correctly, but I'm just picking a number at random. Say if I put 2 in and I got, say, 0.35. So I know 0.35, if this is 5%, right? This will be 6% onward because this is going to be 5% up until 100%. So I know that the 35% is somewhere here, right? So this region is 35%. It's pointing to 2 here, which means that, hey, if it's in the blue zone, I will just say that accept H now, right? Accept H now since the probability of X, okay, you can use X, you can use lambda, right? In this case, let's say this is N, but normally if it's lambda, we just say X as a Poisson distribution with lambda 5, and then we find probability of big X being less than or equals to 2 is how much, right? So I could say that this is greater than 5%, right? Which we found out to be 35%. So yes, 35% is greater than 5%. Okay, so don't worry about this part. all you need to do for now or understand for now is until part B. That is very, very important here. Yeah. So you can see the practice here. These are the practices that you can do, can set up the hypothesis. So for example, first one, Dimitri wants to see whether a die is biased towards the value of 6. He throws 60 times, okay, and count the number of 6 he gets. Describe the test statistic. So the test statistic is this one, number of 6, right, on the throw. So how many times did he throws, right? Write down the null hypothesis for this. Okay, the null H0. H0 is you want to say the die is biased, right? So let's just say number of 6 here. I will just call it X, right? So if it is biased, then you can say a probability of X being greater than 0.5. Okay, X is number of 6, right? Is what? If it is biased, it is, I'll just say that this is not equals to, okay, or let's say, let's just say H null. Instead of using the probability, I'll just use the term big X. Okay, big X is equals to 0.5. And this small x is not equals to 0.5. Okay, so big X, since we say this, we can say the probability of big X is less than, is equals to 6 is less than 0.5. Okay, or let me rewrite this. Or you can say is bias mean it's not going to be equals. Or you can say it's going to be greater than, right? So in this case, we're saying not equals to. Okay, let's go with not equals to, right? Or you can say this is equals to. So that this is our null hypothesis. See? So it depends on how you set the hypothesis to be.